Hruday, who is joined? Hruday, are you there? Advait? Okay. Just wait. Okay. Can you able to hear me now? So sorry, summers was missed today. Okay, so previous problem where we got the image as a -10. So here it is formed at a distance from the optical center to here. So it is in between the pole and focus, and maybe this image is diminished, it is erect. Okay, and this image is formed on the same side of the lens. Okay, so these are the characteristics, and if you want to define the characteristics of this image formed, you can go for the magnification also. Okay, from there also you will get the answer, so that also we can do now. So magnification in lens, m is nothing but what? V by u. So v is nothing but here we got it as a -10. Okay, you have to take the value with sign, divided by u. U is nothing but what? -30. So here you will get the magnification is 1 by 3. So this is 0 point something, 0.333 we will get the magnification. That means here it is positive. That means it is erect as well as it is diminished image we are getting in case of concave lens. Okay, so this is what the previous problem. Getting this, take a screenshot of this, then we'll go for another problem. Write down next one. Write down next one. If the image formed by a lens, if the image formed by a lens for all positions of an object is placed in front of is placed in front of it is placed in front of it is always erect and diminished is always erect and diminished, comma, what is the nature of this lens? What is the nature of this lens? Question mark. And write down sub question. Draw a ray diagram to justify. Draw a ray diagram to justify your answer. To justify your answer. Full stop. If the numerical value of the power of this lens of 10 diopter comma, what is the focal length in the Cartesian system? What is the focal length in the Cartesian system? Okay, so I'll repeat this problem. If the image formed by a lens for all positions of an object placed in front of it is always erect and diminished, what is the nature of this lens? Draw a ray diagram to justify your answer. If the numerical value of the power of the lens is 10 diopter, what is its focal length in the Cartesian system? Okay, so it's very clear statement, first one. So they are saying image formed for the lens for a different position. All position means what? When the object is at infinite distance, when we are keeping behind the center or in on the center, in between center and focus, in between or on the center, in between pole and center. Okay, so all these different positions, the object means image is formed, and that image is what we are getting always erect and diminished. So erect and diminished in all the cases means different positions. Okay, so in which case we are getting erect and diminished, this is very important. It is also based on this concave lens only. Okay, so here we have the concave lens with us, and we are keeping the object at a different positions. So if you keep the object at infinite distance, okay, this is a concave lens, okay, and we have here pair of foci, f1 here twice of f2, f2 and twice of f2. Okay, so whenever you are keeping object at infinite distance, when you are keeping the object behind the twice f, in between twice f and f1, or in between the focus and optical center, in all the different positions we are changing for this object, and we are getting image on the same side of the object. Okay, and that saying this statement is very important. It is always erect and diminished. Okay, always erect and diminished, that means this is what? The concave lens. Very important. This is nothing but what? Concave lens. Yesterday I told you, in if you check your textbook, NCERT textbook, that table is given. Only a concave lens is there where we got all the erect images. Okay, so if you check the last column, there you can check there is what? Always erect and diminished image by using concave lens. Okay, and these concave lenses are known as what? The diverging lenses. Okay, and here what they are asking, first one, what is the nature of the lens? Nature is nothing but it is nothing but a concave lens we got. Okay, and it is speciality is what? It forms always erect and diminished image. So this is the answer of first question. Okay, and what they are saying, draw a ray diagram to justify your answer if the numerical value of the power. Okay, that is last part. First we have to draw the diagram. So we have to draw a diagram. Then which diagram we have to draw this? So they are only saying justify this statement. Image is what here? They are giving erect and diminished. Okay, they are saying erect and diminished. Okay, that means we have to keep the object in between the optical center and the not optical center, in between the focus and this center. So you can keep the object over here and try to complete the ray diagram. Okay, so suppose this is your A and this is B. So what we are doing, first you have to pass the ray which is parallel to the principal axis. Okay, this is parallel. Okay, somewhere it is comes, gets refracted, and it is appear to focus at point F1. Okay, and from that point it is what gets come out from this lens. Okay, this is the refracted ray and it is appeared to focus at F1. Okay, and another ray of light which is passing through the focus. Okay, or else you can pass through the center. Okay, another ray of light from this object you can draw which is passing through the focus. This is what? The incident ray. Okay, and whenever this is passing through the optical center, then it is retraces back on the same path. Okay, and whenever they are meeting or intersecting with each other, from there you can drop a perpendicular. If you check, this and this is what get crossed here. So from this you can drop a perpendicular. So this is nothing but A dash and this is nothing but what? B dash. So image formed on the same side of the mirror, that's what it is erect and it is diminished. So this ray diagram proves that this is the concave lens, and we also proved here this is erect and diminished. Can you getting this? समझ में आ रहा है क्वेश्चन? Okay, so question is not yet completed. We have to find out the focal length of this. So focal length, that means here power is given. Power is given, that is nothing but 10 diopter, and we know that focal length is nothing but 1 upon power. Okay, so 1 upon power. So here you can write down 1 upon 10 diopter. Okay, so focal length we are taking in terms of meter. So multiply here by 100, divide by 100. Okay, so this 100 goes up after removing this diopter, and you will get focal length as a 10 meter. Getting this? So this is nothing but what? Oh, sorry, not 10 meter, it is 0.1. So wait. 1 upon focal, 1 upon 10, and we have to convert this into meter. So we will get answer 0.1, that is 1 by 10, and this is nothing but we can write 10 centimeter. This is 0.1 meter. This is the answer. Okay. So copy this. This is a focal length we got. Okay, copied everyone, understood. So here power is given in terms of diopter 1 by 10. Okay, but here the thing is that answer is not, we can't write 10. Why? Because this is, we got focal length as a 0.1 meter, but this is what concave length, concave length. So this is the concave length. So focal length we can get it as minus 0.1 meter, or you can write 10 centimeter, minus 10 centimeter. Okay, so remember, don't forget the sign. Okay, here actually they are not asking the any problems and all, but see, they are asking the ray diagrams. Okay, so try to understand what is the given and what we have to draw. That is very important here. This only drawing, the ray diagram is only for given 2 marks, and this focal length problem is for 1 mark. So total question is for 3 marks. Getting this? Now write down next question. Write down next question. An object of height 5 centimeter, an object of height 5 centimeter, an object of height 5 centimeter is placed perpendicular to the principal axis, perpendicular to the principal axis of concave lens, of concave lens of focal length 10 centimeter, of focal length 10 centimeter, full stop. If the distance of the object, if the distance of the object from the optical center, from the optical center of the lens is 20 centimeter, from the optical center of the lens is 20 centimeter, comma, determine the position, determine the position, determine the position, comma, nature and size, nature and size of the image, of the image formed using the lens formula, using the lens formula. Okay, so I will read the question again. An object of height 5 centimeter is placed perpendicular to the principal axis of concave lens of focal length 10 centimeter. Okay, if the distance of the object from the optical center of the lens is 20 centimeter, determine the position, nature, size of the image formed using the lens formula. Okay, so here they are saying this is the concave lens. Again same concave lens is there. So object height is given, that is HO is given plus 5 because it is placed perpendicular to the principal axis. So that is above the principal axis. H is given, that is plus 5 centimeter, and focal length is given 10. So just now we did the focal length of the concave lens is negative. Okay, so we can write it as minus 10. Focal length is nothing but here minus 10, and the distance of the object from the optical center. Okay, from the optical center it is 20 centimeter. So here U is given minus 20. U is given how much? Minus 20. So we have to find out V, and from that they are asking the nature of the image, nature, position, that things they are asking. So very important. So check. I will draw again concave lens here. Okay. So same, we have a concave lens. If you know, then you just plot the given on the by drawing the diagram. It is very helpful while solving the numerical, so that whatever the answer we got, that we can check with these ray diagrams also. Okay, so here we have a focus F, and from the optical center to this focal length is given 10 centimeter, and object is kept at a 20. That means it is kept on somewhere by on twice of F. Okay, so this distance, entire distance from optical center to focal twice F1, that means center is given 20 centimeter. That means from here we can write U is minus 20 centimeter and F we got it as a minus 10 centimeter. Okay, so this is what the given quantity. See, it's very simple. If you read the problem properly, then you will get 50% things. Okay, so we know that lens formula. What is lens formula? Lens formula 1 by F is equal to 1 by V minus 1 by U. So 1 by V we have to calculate. So I will keep aside, I will keep this, and other things I will transpose 1 by F plus 1 by U. So 1 by F is nothing but minus 1 by 10 plus U is nothing but here minus 1 by 20. So minus 1 by 10 and plus minus minus 1 by 20. So here you can make a LCM same 2 by 20. Okay, or here you can write minus 1. Minus, you will get minus 3 by 20. Okay, so 1 by V is nothing but minus 3 by 20. So 3 is nothing but minus 20 by 3 centimeter. Or you can convert this into fraction. So you will get that also okay. But right now I will keep the answer as it is. So V I got negative. So negative, that means it is what? Erect image, and we are getting what? This is another nature of this. Erect, as well as we will get not erect, virtual we will get. Okay, virtual image we are getting here, and diminished image we are getting. Not diminished, yeah, not virtual also, it is erect only because it is minus, no, it is forming in front of the mirror. Okay, so Vi got somewhere minus 20 by 3. Minus 20 by 3, that means somewhere in between the focus and center we are getting this. Okay, so once you get V, then find out the nature by using magnification. In magnification we have HI by HO. Okay, HI means image height by object height, as well as we can write here V by U. So I will take here V by U, and this is what the magnification formula. So from this we can find out the magnification. Okay, so I will take only HI by HO is equal to V by U. So I want to find out here HI I have to find out. So V by U into, we can multiply HO, and V I have how much? Minus 20 by 3, and u I have with me, that is minus 20 into HO is given how much? 5, no? Yeah, that is HO is given, object is placed 5 centimeter perpendicular to the principal axis, correct? So here object is given 5, that is 5, okay? So this is minus 5, this minus is get cancelled, okay? 20 by 3 and this 20 this multiplied by 20 into 5, so this is get cancelled and you will get the answer 5 by 3 something 1.7, okay? This is nothing but what? Centimeter is a HI image we are getting, okay? So HI is nothing but 1.7. see here magnification we got, means object height, image height I am getting positive 1.7, okay? So that is also formed above the principal axis, and it is what? Diminished over here, and we can say that from this we can say that the image is what here? Virtual, and image is erect and diminished one, understood? So this is nothing but the nature and position. Getting this question? So U and F, calculation of U and F is very important, and then use lens formula and substitute and calculate the answer. Copied. Then write down next problem. Write down next one. Everyone can take a screenshot or they can copy this. Hruday, are you there? Hruday, Advait, who all are there? Hruday, are you there? Can you able to hear me? Avni, are you there? Advait? Okay, Advait is sleeping. Very nice. Okay. Write down next one. An object is placed at a distance of 30 centimeter object is placed at a distance of 30 centimeter from a concave lens of focal length, of focal length 30 centimeter. An object is placed at a distance of 30 centimeter from a concave lens of focal length 30 centimeter. Full stop. First bit, use lens formula to determine the distance. Use lens formula to determine the distance of the image from the lens. List four characteristics of the image list 4 characteristics of the image. Okay. Third bit, draw a labeled diagram to justify your answer to justify your answer from second bit, from the second bit. Okay, so this again I will read the problem. An object is placed at a distance of 30 centimeter from a concave lens of focal length 30 centimeter. First, use lens formula to determine the distance of the image from the lens. Second, list 4 characteristics of the image. And third, draw the label diagram to justify your answer of the part B. Okay. So in mirrors we are measuring the object, image and focal from the center or from the pole. Okay, we are measuring from the pole. And in lenses we are measuring all the distances, means focal length hoga ya u and v, we are measuring with the help of optical center. Okay, so sometimes these kind of questions are also asking. The distances are measured in a mirror is from pole, and in case of lenses the distances are measured from the optical center. Very important. Okay, now here in this question, object is placed at a distance of 30 centimeter from the concave lens of focal length 30. अभी क्या है again, u is also negative and f is also negative, so find out v. V you will get definitely negative. Okay, check your answer. So after doing 2-3 problems, now we will get the idea. If wherever the concave lens will come, then always concave lens you are getting f is negative, and if it is kept in front of the mirror, then that u is also what, negative. So definitely v is also what, coming negative only. So after solving, practicing this lens problem, you will get the idea what kind of answers we are getting. And after that they are asking characteristics. That means you have to define here what is the nature, position, size of the image in this case. Okay, so first write down the given thing. U is nothing but minus 30 centimeter, and f is also given minus 30 centimeter. That means object is kept on the focus. Okay, that is, from this we can conclude that object is kept on the focus. Okay, so we have to use a lens formula. 1 by f is equal to 1 by v minus 1 by u. So v I want to calculate here, so keep v as it is and transpose the other things. Okay, and substitute here minus 1 by 30 minus 1 by 30 plus minus is become minus, so minus 2 by 30, that is equal to minus 1 by 15. Okay, so v you will get what, 15 minus 15 centimeter. That means the image is formed on the same size of the same side of the object. Okay, so we I got minus 15 here. So magnification we can calculate, so we will get the nature. So second bit, to get the second bit, m is equal to we can write v by u in case of lens. So here v by u, v is nothing but what, minus 15, u is minus 30, so minus minus get cancelled, and you will get magnification is half, that is 0.5. Okay, magnification is unitless quantity, and magnification once you get here minus half, okay, sorry, plus 0.5, then from this we can say that it is what, image is formed on the same sides, that is erect, and then it is 15 centimeter away from the lens on the same side of the object. Size is here diminished, okay, because we got 0.5, and image is what here, erect. Okay, so this is what the nature. And one more thing, in some textbook they are taking the image nature is also virtual, because why it is virtual, so they are taking, we are getting the image on the same side. So here in case of concave lens, the rays are what, appear at the focus, that's what that they are taking here nature. They are writing here, they are taking it as a virtual also. Okay, they are taking virtual. but V is what here we are getting on the same side. That's what we are saying, the image is erect, and because of this magnification we can say that it is diminished and it is formed on the same side. That what same side, that's what we are saying, it is erect. But here the rays are appeared at the focus. That's what we can say that nature is also virtual here. Okay, so this is what the answer for this question. Okay, question is third bit is left, it is not yet completed. So what is the third bit? We have to draw the label diagram for this. So find out. So everyone can copy this first and then we can draw the diagram. Can you getting? Hruday, Avni? Can you able to understand the problems? Hruday, can you getting the numericals? Okay, draw the ray diagram for this question. Okay, concave lens is given. So here only I will try to draw concave lens. This is the principal axis, optical center. Okay, this is F1, this is minus this is twice of F, this is F2, twice of F2. Okay, and then here on focal only the object is kept. So this is what the object we have. Okay, A and B. So initially the ray will pass parallel to the principal axis so that it is appeared at a focus, and then it is what get reflected back. Okay, so this is first ray. Another ray which is passing through the optical center. Okay, another ray I am taking which is passing through the optical center. So this is retraces back on the same path. Okay, so here they are cutting. From that point you can draw perpendicular on the principal axis. So you will get here this as a dash and this as a B dash. So image is what? Diminished, and it is formed on the same side of the object, because V is what here? Minus 15. Okay. So draw this ray diagram. Rays are very important over here. Don't forget to draw the rays, incident ray and refracted ray. Getting this? Hruday, are you there? Hruday, can you able to understand? Can you getting? Avni? Advait? Is Advait joined? Okay. Write down next one. Okay, write down the next question. A concave lens of focal length, a concave lens of a focal length 60 centimeter is used. 60 centimeter is used. 60 centimeter is used to form an image. To form an image of an object of length 9 centimeter, of length 9 centimeter, kept at a distance of kept at a distance of 30 centimeter from it. Kept 30 centimeter from it. Full stop. Use length formula. Use length formula to determine the nature, position and length of the image formed. Length of the image formed. Length of the image formed. Full stop. Also draw labeled ray diagram. Also draw a labeled ray diagram to show the image formation. To show the image formation in the above case. Okay, I'll repeat this question. A concave lens of focal length 60 centimeter is used to form an image of an object of focal length 9 centimeter kept at a distance of 30 centimeter from it. Use lens formula to determine the nature, position and length of the image formed. Also draw a labeled ray diagram to show the image formation in the above case. Okay. So here it is, from after reading this we come to know that this is the concave lens. Okay. So concave lens का जो focal length is given, that is nothing but here minus 60. Lens is having focal length is minus 60 and image of an object is 9 centimeter kept at a distance of 30 centimeter from it. Because something different question is there. Okay. So object of length is nothing but height. Okay. So here h is nothing but here 9 centimeter. Okay. Object जो है, object height HO is given 9 centimeter and that is kept at 30 centimeter from it. Means from the optical center the object is kept at 30 centimeter, and as this is a concave lens, so u is also what here, negative, that is minus 30. Now we have to calculate the v. So again, as we did many numericals, now we come to know that concave lens है तो focal length negative, u is also negative and v is definitely we are getting what, negative only. Okay, so this is what the understanding part. So this is a trick. So concave में क्या है, v is negative, u is negative and f is we are getting what, negative. Okay, so first write down the given things and then calculate the v. Once you calculate the v, then they are asking us to find out the length, position and nature of the image formed. So you have to find out the hi. Okay, hi we have to find out. Then we have, once you find out hi, then you can define the nature of that image formed and then we can go for the diagram. Getting this? Okay, so write down the given things over here first and start solving. You can start yourself and verify the answers with me. Okay, so here u is given how much? U is minus 30 only, no need to erase. So u is here minus 30. Focal length is get changed, that is minus 60 and HO object is given here plus 9 I think, correct? So 9 centimeter on the principal axis. So this is the length formula. So V only we have to calculate. Focal length is nothing but here 60. This is minus 30. So take a LCM here. So you will get it as minus 1 minus 2 upon 60. So minus 3 by 60, that is nothing but 1 by 30. Oh, sorry, 1 by 20. This is nothing but 1 by V with minus sign, and V is nothing but, we can write here, V is nothing but minus 20 centimeter. Okay. So this is nothing but what, your V. V again we got minus 20 centimeter. Now we have to find out magnification. Then only we can define the nature and position. So in case of lens, magnification is U by V, as well as here we can draw it, we can write it as HI by HO. Okay. So U is V, just now we got minus 20, U is minus 30, HI we have to find out, and HO is given 9. So here minus and minus get cancelled. So therefore HI, therefore we will get HI is nothing but here 2 by 3 means 3 3s are 9. 6 centimeter we are getting the answer. HI is nothing but 6 centimeter. So here once you get 6 centimeter, then here image is what? As the V we got on the same side of the lens, so that is nothing but erect. Okay, but as the rays are appeared at the same side of the object, then it is known as what? Virtual. So virtual, and then image is what here? Diminished. Okay, because HI we are getting 6 and HO is given 9. So initially it is at a bigger height, now we are getting smaller height, that means it is diminished. Okay, and where it will form, it will also form in front of the mirror, because this is given 20. So if you are trying to draw the diagram, ray diagram, check here. So I will draw here. This is nothing but concave lens. This is the principal axis, optical center. This is f1 and this is twice of f2. So focal length is here minus 60 and U is kept 30. And that means it is somewhere kept over here. This is what the object, this is A and B. First ray passing parallel, okay, and it is what? Passing through the focus. It is appeared at the focus, and then it is what? Gets refracted. Another ray of light which is passing through the focus, okay, and passing through the optical center, then it is retraces back on the same side, okay, on the same path. So you can, where they both are meeting, intersecting, from there you can drop a perpendicular. So I will get this as a dash and this as what? B dash. Okay. So this is what the ray diagram. Getting this? समझ में आ रहा है? Rays are very very important in this case. So whatever the calculations we got, according to that we are getting the diagram. You have to verify with that also. Okay? Getting, everyone is getting? सबको समझ में आ रहा है? Okay, so write down next question. Write down next question. Everyone took a screenshot getting the numericals, getting the ray diagrams. Is Advait joined? Hruday? Hriday, are you there? Okay. Okay, write down next question. Chalo. First beat. Next question, and that question contains 3 sub questions. So first question, first bit you can write down. Draw a ray diagram. Draw a ray diagram to show the formation of image. Draw a ray diagram. Draw a ray diagram to show the formation of image. To show the formation of image by a convex lens. By a convex lens. By a convex lens. When an object is placed. When an object is placed in front of the lens. When an object is placed in front of the lens, between its optical center, between its optical center and principal focus. And principal focus. Full stop. Second bit write down. In the above ray diagram, mark the object distance u. Mark the object distance u and image distance v. Image distance v with their proper signs, positive and negative as per new Cartesian sign conventions. As per new Cartesian sign convention. And state how these distances are related to focal length f. Related to focal length f of the convex lens in this case. Full stop. Third bit, find the power of convex lens. Find the power of a convex lens which forms a real and inverted image of magnification -1. Magnification -1 of an object placed at a distance of 20 centimeter. Placed at a distance of 20 centimeter from its optical center. Okay, so I will repeat each bit again. Draw a ray diagram to show the formation of image by convex lens when an object is placed in front of the lens between its optical center and principal focus. Second bit, in the above ray diagram, mark the object distance u and image distance v with their proper sign, positive or negative as per new Cartesian sign convention, and state how these distances are related to focal length f of the convex lens in this case. And third bit, find the power of the convex lens which forms real and inverted image of magnification -1 of an object placed at a distance of 20 cm from its optical center. Okay, so this is what the 3-mark question. So 1 mark is allotted to each bit. Okay, so here the ray diagram to show the formation of image by a convex lens. Okay, so just now we did many problems on concave. Now the convex case. Okay, so convex, you must know how to draw the convex lens. Okay, image formation and all that we can see it later, but you should know how we can draw the convex. Okay, so this is nothing but what your convex lens. Okay, this is what center, optical center, pass one line. This line is known as the principal axis, and this is optical center O. Okay, so they are asking here, draw the ray diagram to show the formation of image by a convex lens when the object is placed in front of the lens. In front of the lens, okay, between its optical center and principal focus. Okay, so this is what f. This is nothing but twice of f. You can take it as a 1, and this is nothing but f2, and we have a twice f2. So optical center is O. Okay, and object is kept where? Here. Okay, in between optical center and focus. Getting this? Okay, so at least by reading you can draw this much diagram. Okay, and then you have to just be whatever the rules we learned for mirror and lenses. Okay, the same rules which we learned in the lenses, that only you have to apply over here. Okay, so object is kept here. Okay, that means we have to pass the first ray, which is what? Parallel, which is parallel to the principal axis. So this is a parallel ray. Okay, and when it will go inside the lens, there is a refraction. Okay, then what will happen in this case? Here, when you are passing the ray parallel to the principal axis, it is passing through the focus. Getting this? And another ray which we are passing through this optical center. Now see, those both are, the refracted ray are not meeting, and the ray which is passing through the optical center, that is refracted back on the same path. So they are not at all meeting together. So they are going what? Wide apart, as they are going for a long distances. So they are not meeting. So in this case, what we have to do? We have to just extend these rays in the backward direction. Okay, and somewhere while retracing in the backward direction, they both are meeting or intersecting. So where they are intersecting, from that point you have to draw a perpendicular on the principal axis, so that you will get the image. Suppose this is A and B, so this is nothing but your A dash and B dash. Okay, so this is what the image we got. Okay, this is only first diagram. They are not asking anything over here. This is the first ray diagram we got. Okay, according to their information, we kept the object in between the optical center and focus. Okay, now they are asking in second bit, show U, V and focal lengths and all. So B means AB is a object, so here I kept this, and in this case U is nothing but what? Here negative. center to object distance is always u. Object means I am looking towards the lens or mirror. So u is nothing but what here? Negative. Now focal length. So focus to the optical center is f. Okay, and this f is also what here? Negative in this case. Oh, sorry, not negative focal length. So this is not a focal length. We are taking there, no. So focal length we are getting here. Okay, focusing. So this is nothing but focal length f, which is positive, and then we got the object on the same side of the lens. So from here to the optical center, this is nothing but what? V, which is also negative here. Getting this? Okay. So this is nothing but what? Your u, v and f distances. And we know that what is a image object distance, that is using lens formula. We know that 1 by f is equal to 1 by v minus 1 by u. Okay, so this is nothing but the lens formula we have. And from this third bit, what they are asking here, find the power of the convex lens which forms the real and inverted image of the magnification -1. Okay, this is entire different bit. -1 of an object placed at a distance of 20 centimeter from its optical center. Okay, so here this is not related with this. This is something else, because they are saying magnification is -1 and u is given here -20. So these are the different bits they give. So don't relate that with this diagram. Okay. So here write down the given quantities. Magnification is given -1, u is -20 centimeter here. Okay, because the object is placed in front of this mirror, in front of this lens. So u is -20. So we have to find out here v and we have to find out f. Okay, as we don't have a focal length, so we can't use the lens formula also. Okay, so here we have one more formula, that is the magnification we have. So we know that magnification m is nothing but v by u. So here magnification is -1. So v and u is given -20. So here I will get v is equal to what? 20 centimeters. So this is what the v I got first point. And then second they are asking focal length. Okay, so focal length, how can we calculate here? Focal length is nothing but what? Here 20. Focal length we have to find out. How to find out the focal length? Their focal length also they are asking, and even focal length you can calculate here by using lens formula. So 1 by f is nothing but 1 by u. U is nothing but here 20 and minus of -1 by 20. So here this is nothing but minus and minus will become plus. 2 by 20, that is nothing but 1 by 10. So focal is nothing but what? 10 centimeter. I got focal length is nothing but here 10 centimeter. Getting this? So once you get the focal length, then you can calculate. They are asking power also. So power is nothing but what? 1 by f. Okay, substitute the value 1 centimeter here. Focal 1 by f is nothing but what here? 10 centimeter is there. That means I am multiplying with -2 to convert this into meter. Okay, so in this case you will get the answer 10 diopter, because this time -10 will go up, so that will become 100. 100 by 10 is nothing but what? You will get 10. Okay, so power, so as is a concave lens, a convex lens, power is always we are getting what? 10. So power is nothing but plus, that is plus 10 diopter. This is the answer. Getting? So copy this. Can you getting the problems? Does anyone have problems or not getting, not understanding? Hruday, Avni, can you able to? get these problems. Others who all are joined can message. Hruday, are you there? Avni, are you there? Okay, we'll do some other problems also, so you can take 15 minutes break. Okay, so I will send a new link, so again we can do the numericals. Okay, some other numericals from the same chapter. Okay, we can meet after half an hour. I will send a new link.